this is a really nerdy answer. I've always liked battery systems. Like on a highway, there's a lot of other cars. There's pedestrians walking around at one speed. There's bicyclists crossing around. The cars, trucks, buses, all of these different things, and they're all doing different things on the same bit of road. So the challenge here is to be able to look at all of these different things, understand what they're doing, turn that into something that the vehicle is able to act upon. So all of these cameras that we've put onto our truck, they actually create a map. So imagine you're playing a video game and you're moving your character around and you've got a map which tells you where the bad guys are, where your friends are, where the buildings are all around you. And we're doing that in our truck so that we can build a map that the truck can see. And what that will do is allow the truck to be safer. It allows it to see you when you're crossing the road. When we talk about drive-by-wire, what we're talking about is replacing those mechanical, physical connections with digital, electrical connections. So now, instead of the human physically moving controls that have outputs, the driver provides inputs, still in the same ways, to the steering wheel, to the accelerating pedal, to the braking pedal, and that is now read by a computer. It's the same way that when you're playing your video game and you've got your controller in your hand, when you push the thumbstick forward, it sends an electronic signal to move your character forward. And that's the same thing we're doing inside the truck.
You're listening to Bite-Sized Climate Tech, Season 4. Let's dive in.
Time to make climate cool again.
Today, I have the CEO and co-founder of Bristol Superlight, Noamaan, with us.
Hi, it's a real pleasure to be on the show.
He has a very cool company doing cool things.
So we're basically reinventing trucks from a clean sheet. We've got a really futuristic electric truck that's got some really advanced sensors on there. We're the leaders in the world in terms of sustainability, in terms of cost, but also in terms of safety.
So in terms of safety is the concept that we're going to talk about. This cool concept is called perception system.
So perception systems refer largely to vision systems and other perceptual detection systems on machines like robots or autonomous cars or autonomous trucks. So that machines that operate in the real world, whether that's a robot building something in a factory or a car driving along on the highway, are able to detect what's in the world around them, and they're able to act on that world.
How do you make it work?
We start with a digital vehicle platform. The whole system is drive-by-wire. The vehicle accelerates by wire, brakes by wire, steers by wire. And then on top of this, we layer a network of 15 high-definition cameras all around the vehicle, which we then take those visual imagery from those cameras, and then we do a lot of onboard computation to turn that into something usable for the vehicle, and that helps us enhance safety by, for instance, detecting pedestrians, bicyclists, other road users, and being able to perform vehicle actions like emergency braking or notifying the driver that he's going to run into something.
The perception system, so I understand, is a kind of sensor fusion system. In my previous episode, they talked about their sensor fusion system actually detect different things. Some of them can detect the distance, some of them detect the height and sound. How is yours unique or different?
The concept of sensor fusion is broadly similar. We take data from different sensors and then we do some computation on them and integrate all of this data to be able to create actionable outputs for the vehicle. What that means is that we're able to take camera data from forward-facing cameras, rearward-facing cameras, side-facing cameras. We're able to create then a world view of what the vehicle has going on around it. On a highway, there's a lot of other cars. There's pedestrians walking around at one speed. There's bicyclists crossing around. There's scooters. There's cars, trucks, buses, all of these different things, and they're all doing different things on the same bit of road. So the challenge here is to be able to look at all of these different things, understand what they're doing, and then turn that into something that the vehicle is able to act upon.
For the camera, you take in different data and then you create a whole image for the system to act.
There's a few different things there. When you look at some of the forward-facing cameras, that's where we're doing our classifier and some of our object detection. When you look at some of the other cameras, they are doing distance and building up the overall pictorial view. There are systems like radars and lidars, which are detecting distances and vehicles in slightly different ways. And all of these different systems work together to build up a cohesive picture of what's going on around outside.
And then you talked about the drive-by-wire. Drive-by-wire is perhaps it's a a common concept for electronic engineers like yourself, but for me or people who don't have an engineering degree, when you compare drive-by-wire, what is the other alternative that you're comparing to?
The historical paradigm in the automotive industry and what we used to do is where everything was physically connected to the driver. So when I turned a steering wheel, it was connected to a metal shaft, then physically steered the wheels. When I pressed the gas pedal, it would pull a cable that would cause the engine to develop more power. When I press the brake pedal, it physically pushes a cylinder that causes the brakes. So I'm physically connected to the different systems in the vehicle. When we talk about drive-by-wire, what we're talking about is replacing those mechanical, physical connections with digital electrical connections. The wire in question is electrical wire. So now, instead of the human physically moving controls that have outputs, the driver provides inputs, still in the same ways, to the steering wheel, to the accelerating pedal, to the braking pedal, and that is now read by a computer. And the computer then interprets what the driver wants to do and then sends digital signals to control all the different elements of the vehicle to carry out that function.
You told me a pretty cool thing is actually being done also in the airline industry.
That's right. Fly-by-wire was invented for the US space program in the 1960s. The lunar lander was the world's first digitally controlled fly-by-wire vehicle. Combat aircraft have been fly-by-wire, where all of these mechanical inputs were replaced with digital inputs since the 60s and 70s. And then since Boeing came out with the 787 Dreamliner, pretty much all modern aircraft for civilian use and commercial use are fly-by-wire as well. The aviation industry has adopted this because it's safer, it's cheaper, it's more reliable, you can build in more redundancies. So in the automotive industry, well, cars are starting to make that shift now, and some of the modern cars are like that, but I think the trucks and buses are still a long way to go, which is where we come in, because our system is a digital drive-by-wire platform from the ground up.
How would you explain this to an 8-year-old?
When you're walking to school and you see buses and trucks driving around or cars on the road and you're waiting to cross the road, right now all of these things need a human to look at these with their eyes, and sometimes the person inside the car doesn't always see you. And so by making our cars and trucks and buses smart, by giving them eyes to see, we can then help those cars and buses and trucks. All of these cameras that we've put onto our truck, they actually create a map. So imagine you're playing a video game and you're moving your character around and you've got a map which tells you where the bad guys are, where your friends are, where the buildings are all around you. And we're doing that in our trucks so that we can build a map that the truck can see. And what that will do is allow the truck to be safer. It allows it to see you when you're crossing the road.
You'll be able to better play this video game.
Exactly right. We get better and better, and the truck is capable of building more and more detailed maps and then being really smart about what it can do to brake so it doesn't hit you or to tell the driver that you're crossing the road.
The reason why the video game can work is you have the system that build up all of those information.
That's right, and we need to create that from scratch because that's not programmed in, right? So we need to be able to see things, we need to be able to detect things, and then create our own maps using computers on the truck.
The drive-by-wire, how are you going to explain this for AO?
It's the same way that when you're playing your video game and you've got your controller in your hand, when you push the thumbstick forward, it sends an electronic signal to move your character forward. And that's the same thing we're doing inside the truck with a steering wheel and with a gas pedal and with a brake pedal.
Our next segment is you're going to answer a question from a previous guest. How are we going to hand over the world to our children and grandchildren in a better place than it is today?
So what we're going to do, we're going to work really hard to create technologies that will be able to help reduce the heating on the planet, that will be able to make a safer environment, and that will output less pollution. And that way we improve lives, we save lives, and we result in a better planet.
Is there anything that you think personally you can do?
Yeah, it's really straightforward. Use the car less, use less electricity, try to be more mindful about what you buy. And the most important thing is all of the cheap toys, all of the little gifts that you learn how to say no to them, because they're all using plastic, they all have to be shipped across from different countries, and that's really bad for the environment. I know it's a little bit of fun, and I know it's a difficult thing to do, but the best solution here is start saying no.
Become more mindful as a consumer and say no to things that we don't need.
That's exactly right.
Do you have a question that you can leave for the next guest?
It's How are we going to get children to become more interested in science and technology so that they can become the scientists and engineers of the future who are going to continue to build systems to help with the climate crisis?
Awesome. It leads up to the next question is why did you decide to work in climate? Who inspired you to become the engineers for the future? Do you remember when was the first time when you decided you say that I want to build an electric truck company?
This is a really nerdy answer. I've always liked battery systems. I did my undergraduate degree, I did my thesis on battery systems for my lecturer's boat. And so once I finished university, I love transport systems, I love batteries, so it was natural for me to go into the automotive industry working on electric car batteries.
So when you were a kid, did anyone inspire you to go into the field of electric batteries, or it's just a natural interest?
So my dad was an inventor. He was also very excited about electric vehicles, so I grew up in an environment where electric vehicles were normalized, and so it was very natural for me to say, hey, look, I want to go and study electronics engineering because I think this is going to really take off in a big way.
So this is why you're also trying to inspire other people like your kids and the kids who are going to watch the video to become the engineers of the future. The last segment of the podcast is you're going to leave one sentence of hope with our audience.
There's a lot of people, a lot of very smart and talented and capable people who are all working every single day and quite often a lot of the night as well to try to help fix the planet, who are trying to mitigate the impact of climate change and who are trying to build a better, safer world for us. Let's make climate cool again.
High five.